Okay, what we had in previous session was the barber shop example. When the customers came to the barber shop, they went to the waiting area, and then they went to the barber, got the service, and then they left finally. Can you tell me what are the 4 steps that we went through to build that model or any simulation model?
So we followed the leap. So we did first locations, then entities, then arrivals, and then processing.
Then the processing. So in the locations, what did we specify? We specified all the locations that exist in the model. What is the definition of a location? What is your understanding of what is a location? Yeah, it's a basically location or place where the entities go to get processed or just wait for some operations. That's what location means. And can someone tell me what is the meaning of capacity for a location?
It's how many entities that location can hold and process at the same time.
Exactly. It's how many entities that location can hold and process at the same time. So if I have a location that can, let's say if I have a machine that can process 3 parts at the same time, then I change the capacity to 3. If I leave the capacity as at 1, that means that operation can process 1 entity at a time. And if I leave it as infinity, meaning that that location can hold infinite number of entities at the same time. Then that's usually what we put for the waiting areas or the arrival areas and so forth. So if you don't want to limit how many customers can come to this barber shop, so you put capacity of infinity for the arriving areas so that no matter how full they are, still when the new customers are generated by the model, they can come and wait in the waiting area. Can someone tell me what is the meaning of units for the location?
How many of these locations you have?
How many of that location you have? So for example, if I'm modeling a barber shop, when there are 3 barbers and customers can go to any one of them and then leave the system, then that in that scenario for the barber number of units, I put 3. So these units shows the number of parallel locations that can work. And by parallel, I mean there are 3 of them that are doing the exact same work. When an entity comes, entity can go to any one of them and then leave. So that's the meaning of units, number of parallel locations that are doing the same work, and the entity can go through any one of them and then leave the system. And then we went to the second step, we defined the entity, and then we went to the third step, we defined the arrival. When we define the arrival, obviously we define what is the entity and where does the entity go first. When the entity enters the system, where is the first location the entity goes to? This is very important. If you wrongly identify where the entity goes to, that can affect the rest of the process as well. So where is the first place that the entity goes to when it comes to the system? Can someone tell me what is the meaning of quantity each?
Is it how many of the entities can come in at one time?
Yes. At each time when an arrival happens to this system, how many entities enter the system together? When I put 1, that means these customers can come to the system one by one. If I'm modeling the systems in which the arrivals happens in groups, for example, I'm modeling a restaurant, and then this is what I know. The customers arrive to the restaurants in groups that has size 4. So that means 4 in each arrival that happens in the system, 4 customers arrive to the system at the same time. They go through the rest of the process one by one, but the moment that they enter the simulation, the moment that enter the system, 4 of them come together at the same time. They go to the waiting area, but then they go through the barber and through the rest of the process one by one. That's what it means. If you are modeling a manufacturing process and your arrivals are in batches, like you get a batch of 100 parts and things like that, you always define that in quantity each. You put 100 as if when an arrival happens, you get 100 parts. They go through the rest of the process one by one, but they enter as 100 parts all together. And if this is not, if this value is not even fixed, for example, I tell you that I'm modeling a restaurant in which the size of the customers come in groups that vary in size between 2 and 4. So I'm modeling a restaurant in which customers comes in groups and the size of the group varies between 2 and 4. So people can come in groups of 2 people or 3 people or 4 people. And this is uniformly distributed. So the size of the group varies between 2 and 4, uniformly distributed. I can also specify that here in quantity each. How do you think I would write that? So the size of the group is not fixed. It's not fixed 4. It's not fixed 1. It's variable. It varies between 2 and 4, uniformly distributed. So how do you write a uniform distribution that varies between 2 and 4 in ProModel?
Would it be with U and then the mean and then the half width, right?
Okay, what is the mean? Between 2 and 4, what is the mean?
3,
And what is the half?
2.
Between 2 and 4. If the middle is 3, what is the exactly half width? Basically means from the middle to the max, from the middle to the mean. That's half width. So from 3 to 4 is 1, from 3 to 2 is 1 as well. So I would define it like that. So this every time a arrival is generated in the model, then the size of the group versus the number of entities that come to the system is coming from this uniform distribution. Varies between 2 to 4. Okay, we can do that as well. So I'm going to just leave it as 1 as our default. What does first time mean?
Does it start?
The entities can come to the system, the arrivals can happen in the system from the start of the simulation. So that's when we say 0, that means from the start of the simulation. As soon as we start the simulation at time 0, the entity can potentially come to the system. And then occurrence, what does occurrence mean? This is a very important column.
How many customers we're allowing to come into the system over time? So like, since we have infinity, that means we don't have like a limit on how many customers can come in?
Exactly. Infinity, so our occurrence means customers can come to the system over the simulation time, over the simulation run. How many entities are allowed to come to the system? When you put infinity, that means for as long as you run the simulation, entities would come to the simulation. But when if I'm modeling the scenarios where I want to know, okay, in a manufacturing process, how long does it take to process 100 units? So then for the occurrence, I put 100 because all I care about is that 100 parts or 100 entities come to the system, they get processed, and then I want to look at how long did it take to process that 100 units. That's all I care about. So after that, I want to stop the simulation. After that, I don't want it to continue running. So the simulation stops as soon as 100 parts have come to the system and have been processed. So that's basically occurrence. That's what occurrence means here. So most of the times we put infinity because we want the entities to come to the system for as long as we run. Is there a question? Okay. Then we have frequency. What does frequency mean? What does frequency mean, guys?
It tells us what kind of distribution they're coming in, and then depending on that, we use like the mean or standard deviation.
Can you repeat one more time? Sorry.
It tells us the distribution and the mean of how often people come through.
Okay, can you tell me exactly? So in terms of the arrival process, we provide the information either through arrival rate or inter-arrival time. Which one of them we have to put here?
Inter-arrival time?
Inter-arrival time. Very important, guys. You may, in the problem, have arrival rate, but what you need to put in the frequency is inter-arrival time. So what does E10 mean?
Exponential.
And then the average is 10.
Inter-arrival time has average 10, exponentially distributed. That random variable, which represents the inter-arrival time, is exponentially distributed. That's what we put here. If it's fixed, if it's just 10 minutes, I don't need to specify any distribution. I just put it as 10. If it's random, I specify the distribution of the random variable as well. And if let's assume this is 10 minutes, do I have to put unit of time as well?
No, because it's already default at 10
Where do I check the default?
in file info.
Here, I can see the default unit of time, minute, and the default unit of distance, feet. If it's minute, then I don't need to specify minute next to every time that I put in the simulation. If it's not minute, if it's hours, seconds, or anything else, then I need to do that. If I'm developing a model in which all the times are in hour, then I'll come here, I change the default unit of time to hour, then I don't need to write down HR next to every time that I put in the simulation model. That makes my life a lot easier to change the unit of time, the default unit of time to hour. But if it's not the case, if most of them are minutes, just keep it at minute. If you have something in hour, just put HR or second SES next to it. Okay. And then we went to processes. And in the processes, we specified the path that the entity goes to in the system, and then the processing time in each one of the operations. So here entity goes from the waiting area to the barber, and then from the barber to exit. And at barber, they spend about this much time for the haircut. But in waiting area, we don't explicitly hold them for doing something. It's just a waiting time at the waiting area that simulation automatically calculates for us behind the scene. Okay. So in previous session, I told you how to do this. We remember we click on each one of these and we pick the location or the entities and so forth. But I want to tell you another way, maybe an easier way to be able to do it. If you have complex model, maybe that method takes less time to do as opposed to just click to find out the entity and the location and so forth. So to be able to do that, I want you guys to, in this same model, I want to delete these two operations that we have already identified. And so to be able to do that, so we want to define the operations again together. So let's pick select the first row and then right click, delete. And select the second row, right click, delete. So I want you guys to remove the operations, the processes, so that we can define them using the other way. Everyone did that? Please have your model from previous session open and then delete the two processes we defined in the processing. Everyone is good?
Yes.
Okay. Then what I want you to do here at the bottom, do you see the tool menu, tool tab? Click on that. And then you see here the list of your entities. Do you see customer? Select that. So if it's something else selected, don't. So just make sure the customer, your entity is the one that has been selected. Okay. Then so what do we want to do next? We want to go from waiting area to barber. So then I click. The reason is that we already know the customer is in the waiting area. In the arrival, we told the simulation that when customers come in, they go to the waiting area. That's the first place. So the customer is already in the waiting area. So then we want to go from waiting area to barber. Click, click. And when you do that, you see the first line is automatically created for you. The customer goes from waiting area, and then the same customer goes to barber. So basically the customer who is already at waiting area is coming out and then goes to the barber. That's how we read that line. Okay, so as opposed to you click on the locations and on the entities, you can just easily say click, click, and the first line is created for you automatically. Now, where does the customer go next? Then we want the customer to get the haircut done and go to exit. So then the customer that is already at the barber, so the customer is already at the barber in the next line. Barber click. Then the customer wants to go to exit. And exit is here. You see here, route to exit, click on that.
Professor, you broke out for a second. Would you mind doing that again?
Sure. So in the last, then the customer goes from the barber to exit. If you click, let me delete that and do it again. Then when you click on the barber, then we want the customer to go to exit. Exit is here, route to exit. Do you see that? Route to exit, click on that. Then the exit is created here. So in the second line, then customer goes from the barber to exit. Okay, so the first line, waiting area to barber, and then second line from barber to exit. And we also put the processing time at the barber because the customer's haircut takes between 8 to 10 minutes. And this is what we had to put, wait, U91. It was uniformly distributed between 8 to 10. And make sure to save, guys. So this, especially when you guys have big models with a lot of locations, the click method is a lot faster than double click on every one of them and pick the locations and entities yourself. So see which one works better for you. Both of them are fine. I don't mind any one of them, but it's good to know both. One more thing that is good to know here, later we will learn that here in the operation, we may want to write lines of codes. To be able to do that, you can double click on the operation here, double click. You see here, the operation thing opens. And already this one line of code is already here. So if you want to write other lines of code, you just say, you come here and then you just write your code. We will get to that part actually. We will write lines and lines of codes in the operation. And similarly for the move logic, here you see, if there are things that I want to write here, you can either write it here or you can double click in this area and then the move logic window opens here. And then you can start writing your codes here. I will get to that as well. So we'll also use move logic a lot. We'll write codes and things like that. So if you, in your model, sometimes you see these tabs are open, that's fine. You can close them if you don't want them. And all you have is tools. You can close tab on as well if you don't need it. Okay, everyone is good so far?
Professor,
Yeah.
I didn't catch, how do you do the second line with the arrow from the barber to exit? Could you show that one more time, please?
Just click on your barber and then click on the route to exit.
Okay, thank you.
Do you want to try it and let me know if it works?
Yeah, it worked, Professor. Thank you.
Sure. Yeah, so when you want to identify the processes, just pick the entity that you want to define the process for and just click, click means going from this location to this one. Click, click means going from this location to this one, and just continue that till the whole thing is over. Okay, so make sure to save your model, guys. What I want you guys to do next is that I'm going to show you a problem statement. This is the problem statement. I want you guys to read this problem statement carefully and then develop a simulation model on your own. So this is individual practice. So read the problem statement carefully. Make sure you can extract the information related to arrival process and to the service process from this information. But that's what we learned in previous week. And once you are done with that, then start developing the model. And you have the 4 steps that you have to go. It's location, entities, arrivals, and processes. Leap.
You want us to delete our old one?
No, keep it. Everything, keep it. So
Okay.
create a new, okay, this is what we are going to do. Create a new model in the folder for week 2. Name the model as week 2 dash Bank of America ATM, BOA ATM. Okay? Or ATM, it doesn't matter. So create a new model in the folder for week 2. That's what we did always, right? We go to the file, new, and then save this model in the folder for week 2 and name it as week 2 dash ATM or BOA ATM, it doesn't matter. And then start building the model. Read the problem statement carefully and then start building the model. Okay, so here you have your locations. There are 2 locations, one for the line and one for ATM. Make sure to put the label of your locations. Okay, so this is the problem statement that we have. In Bank of America ATM, on average, 20 customers per hour arrive to the ATM. Is this information related to arrival or to the service process?
That is the arrival.
Because it says 20 customers arrive to the ATM, right?
Mhm.
On average, 20 customers per hour. So what type of information is given to you? Is it arrival rate or arrival or inter-arrival time?
It is the arrival rate
Because
it's per hour.
because it's per unit of time, customers
Per
per unit of time. So what is given to you is arrival rate. Is this fixed or variable?
That is a fixed
Why?
because it's 20 per hour and it doesn't have a deviation on it.
What is the keyword that you have to look for to find out if it's fixed or random?
Oh, average.
The keyword is average. On average, 20 customers per hour arrive. That shows this is not fixed. This is random. Average is 20, but maybe next hour we get 10 customers. Maybe the hour after we get 45 customers. Average is 20. Okay, so this shows that the inter-arrival of customers or arrival rate is random. So what else do you have to look for in the problem description?
Look for the deviation of the arrival.
Or even better, which one? What is, even if not the standard deviation, what is the best scenario? The distribution.
Oh, yeah.
That random variable. And what is there anything in the problem statement that tells you the distribution of them?
It tells us that it's an exponential distribution.
The inter-arrival time.
Inter-arrival time is exponential.
Which is the time between arrival of 2 consecutive customers, has exponential distribution. So that's what we have. And yeah, so that's basically what you need to do. So now one other thing is that here you have arrival rate, but what is the one that you need to put in the frequency?
The inter-arrival time.
The inter-arrival time. So then you need to transform the arrival rate of 20 customers per hour to inter-arrival time. So 20 customers per hour. What is their inter-arrival time or the time between arrival of 2 consecutive customers?
3 minutes.
It's 3 minutes. And then okay, so it's 3 minutes. But also pay attention that the inter-arrival time is not fixed, is random. Okay, and the distribution is exponential. So now let's share your model again. Okay.
To be exponential 3.
3. Okay. It can be E capital or E lowercase, it doesn't matter, but it's exponential 3. If you only put 3 minutes, that's fixed 3 minutes between arrival of 2 consecutive customers throughout the whole simulation. But when you put E3, that means average is 3, but it's random, and this random variable comes from an exponential distribution with average 3. Then that would be a random thing in the simulation.
Can we also put E1 divided by 20?
So but then 1 divided by 20, can you stop sharing again? So, okay, that's correct. So inter-arrival time is 1 over arrival rate, which is 20. You are right. What is the unit here? Remember, this is 20 customers per hour. So if I inverse it, then the unit will be inversed as well. So what is the unit of inter-arrival time here? Did I get disconnected, guys?
You cut off for a second.
Yes,
Okay.
Professor.
Sure. I'll repeat again. So inter-arrival time is 1 over arrival rate. You are right, 1 over 20. So my question is that what is the unit here? Given the fact that you know this is 20 customers per hour, that's the unit of the arrival rate. So when you inverse it, the rate will be inversed as well. So what would be the unit here?
Hours per customer.
Hours per customer. 1/20th of an hour per customer, or 1/20th of an hour. That's what this is. However, if you want to write it based on minutes, instead of just saying inter-arrival time is 1/20th of an hour, which is hard to understand what it is. If you want to write it based on minutes, then you have to do, what do you need to do?
You cut off again, Professor.
Okay, so this is 1/20th of an hour. So, but if you want to write it based on the minutes, what do you need to do?
Minutes over an hour.
Multiplied by 60 minutes per hour. And that is 3. What is the unit?
Minutes per
Minutes.
customer.
Minutes per customer. Okay, and that's the one we put in ProModel. Yes,
Okay.
1 over 20 is correct, but the unit of 1 over 20 is hour. The unit of the 3 is minute.
Okay. So for frequency, we should always have it in minutes, or just for like this case.
You can have it in hour, but if you put 1 over 20, make sure to put the unit next to it as hour. If you put 3,
Okay.
then the unit is minute. Both of them are correct, but just make sure you have the right unit. Usually it's 1 over 20 is just hard to understand. What do you mean by 1 over 20? 1/20th of an hour. Just 3 minutes is just easier to communicate. But both of them are correct in simulation. Both of them are acceptable as long as you put the right unit of time next to them.
And then we would put that outside of the parentheses.
Yes. Something like
Okay.
that.
Thank you.
Sure. 3 minutes for E. Both of them are correct. Okay. Bill, can you please share your model again?
Yeah.
Okay, so we are done with the arrival. Let's go to the processes. So the customer goes from the line to ATM in the first line, and then from ATM to exit. And the processing time at ATM is?
Waiting with a normal distribution of 2.4 minutes with a 1.1 deviation.
Yes, with standard 2.4 minutes and 0.1 as a standard deviation. Make sure that the second element that you put for the normal distribution is the standard deviation, not the variance, guys. If I have given you the information in terms of the variance, make sure you transform it to a standard deviation by taking the square root. Okay. And then I wanted you guys to run this for 10 hours. Can you run it? How do you check the simulation time?
Under simulation options, I've set the runtime to 10 minutes or 10 hours.
10 hour. That unit of time is always hour. Okay. And then run it.
I'm sorry, how did you get there?
It's just the simulation options button next to the
right next to
simulate
it.
play button. Do you want me to share the output viewer?
Yes, please.
I'll just share my whole screen. That'll probably be easiest.
Great. So you have about 209 customers that have received the service and have left in 10 hours. And their waiting time in the system is about 8 minutes. So from the moment that they enter till the time that they leave. And out of this time, how many minutes of that is the time they spend at ATM doing their work?
They spent.
You can look at the scoreboard. Yeah.
Oh, 2.41 minutes at the.
That's the time in operation. That's the time at ATM. So what was the other time then? The rest of the time, what happened then?
That was just idle in line.
Waiting in the line. So they were waiting in the line for about 6 minutes, and then they spent about 2-3 minutes in at ATM. If I want to find more information related to the entity, where should I go?
I create a table on the entity summary.
Okay, click on it. Click. Did you click on it? I don't see. Can you click on it? Can you go to table entity?
You're cutting out again, Professor.
Okay, I'm sorry. Okay, here, as you can see, we have customers and they have spent the time in the system is 8 minutes, and about 2 minutes is the time in operation, and about 5 or 6 minutes is the time blocked. Can someone tell me what is the definition of time blocked and the difference between the time waiting? Recall names.
Time blocked is when somebody is in the waiting area, but there's somebody ahead of them doing an operation, so they can't move forward. Whereas time waiting is they're like the second in line or third in line.
That's exactly correct. The block time, basically the waiting time is that you are waiting in the line, right? But you are the second person or the third person or the 10th person or the 20th person. As soon as you become the first person in the line, still you cannot go to the ATM. Someone is at ATM, but you are the first person in the line. As soon as you become the first person in the line, then simulation is going to count that as your block time. Okay, so basically the whole combination of block time and waiting time, both of them together are waiting time. But simulation has ProModel is reporting them separately. As long as you are waiting, but you're not the first person in the line, it is counted as waiting time. But as soon as you become the first person in the line, it's counted as block time. But basically, both of them have the nature of waiting to get to the service operation. Okay, and as you can see here, the waiting time is 0, and the block time is the whole waiting block time. Basically, as if like this, every customer is always the first person in the line. And I want to see exactly why this happens. We will go through continuation of this practice in a minute to see why this happens. But before that, where do you have to go to tell me the utilization of the ATM?
Location utilization chart.
That's one, but where is the other place? In the tables?
Oh, tables, location, summary.
Exactly. Because ATM is a location. So if you want to know about that, you have to go to location summary. But customer is an entity. If you want to know about the waiting time of the customers and things like that, you have to go to the entity summary. So for the location here, what is the utilization of the ATM?
84.3.
About 84% of the time, the ATM is busy. People are working with the ATM. So that's a good level of utilization, actually. We don't want the utilizations to be like 90%, 95%, or 100%, because that's just, if something is working all the time, that means potentially there is also a line of entities waiting to get processed. And that's why the ATM or that machine is working all the time. So a utilization level of about 85% or so actually is good, reasonable. Okay, so can you go back to the entity summary, please? Okay, here. So guys, now we want to make some changes in the model and get a better sense of what this waiting time and what this block time really means. Okay, so for now, I have a location for the arrivals, for the waiting of the entities, and this location has capacity of infinity. And as you can see in the results, I don't get anything in. No worries. In the results, I don't get anything in terms of the waiting time. All I get is the block time. So let's go back to the model and see what we can do to change it. So please stop sharing. Make sure to save your model. Don't save the results, but save the model.
Okay.
Thank you, Will, for sharing yours. Okay. We can make that change in both the barbershop model or the model. I don't have the barbershop, I don't have the ATM model, but they are the same. As you develop both, you know they are the same. Okay, so let's close your ATM model. Let's make this change on the barbershop model. It's just because I have that model as well. So please close your ATM model, open your barbershop model. Okay. And we have the same situation in the barbershop as well. So if I run the model, I see that in the results, when I go to entity summary, again, the time in the system is about 32 minutes. However, about 9 minutes is for the haircut. The rest of 23 minutes is the time blocked, as if every customer is always the first customer in the line. Okay, so we want to see what is going on, why we don't have any waiting time, and why block time is the whole representative of the whole waiting time. Oops. Okay. So to do that, let's here, okay, save your model as. So save as, and at the end of the name, put Q. Okay, so save it as a new model in the same folder for week 2. At the end of the name, put Q and press save. So what I want to do now is to delete the waiting area. So just right click on the, go to the location. I want to delete the waiting area location. So press delete. Do you want to delete? Yeah. It gives me an error because I already have used this location in the processes and in the arrival. So it says you already have used it somewhere else in the model. Are you sure you want to delete it? I'll say yes. And it deletes the waiting area. So now what I want to do is that I want to create a waiting area, but I want to use this icon, Q, conveyor or Q. So to be able to do that, click on the icon and then click and then stretch for as long as you want the length of the queue to look like in your model, and then double click. So that's what I have as a queue. Okay. So just as an example, I'll show it on this side too. Click on the queue and then see here, click. If I do not double click, if I just click, this is what happens. Click, 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 and then double click. So this is just a queue it has created. So if you want to create queues of different forms and shapes, you can just do that. Click, click, click. But whenever you want to end it, just double click. Okay, you can obviously delete because I only need one. And I'm going to name it as waiting area. Is everyone okay so far? My voice is fine?
Yes.
Okay, if it breaks up, let me know so I can repeat it, guys. Okay, so it's waiting area, and I want also to put the label next to it. Okay, good. Now, when this line was created for us automatically, when we created the queue, you can see the capacity is automatically automatically infinite. So when we pick Q as a location, the simulation automatically puts infinite as the capacity. And obviously there is 1 unit and the rest of it is also specified. So, but the capacity of the queues always are set by default as infinite. If you want to change it to 1, 10, or anything else, you can. But the default, if it's 1, okay, just change it to 1. But the default value for a queue is always infinite, or INF, which is abbreviation of infinite. Okay. One other thing that I want you guys to do is that make sure when you create a queue, make sure you click on the queue, not the label, the queue, just double click. And this window opens. Okay, just double click on the queue, this window opens. And here you have the queue or conveyor. By default, it's the conveyor. Later, we will learn, actually, we have one full chapter on how to model conveyors and so forth. Conveyors are the ones that have a speed, have the space. The speed matters, how fast the entities move forward and so forth. But for us, it's just simply a queue. So always when you draw a queue, make sure to double click and change it from conveyor to the queue, always. Otherwise, it does affect your results and it does change your results. So make sure to always pick the queue. And for the length, I will always say keep a short length. Length does not affect the results as much, but if the length is too long, even if it's a queue, the entity should travel from one side to another, and that causes some time, takes some time and makes some changes in the model as well. So I would just leave it as a short length. Okay. So make sure to always double click on the queue and pick it as a queue. Make sure that it's a queue, not a conveyor. Press OK. Make sure to save, guys, before we go forward. Everyone is good so far with me? Are you guys?
Sorry, I was having a little trouble when we're creating the waiting area. What do I click to let go of like the arrow?
Double click.
Double click? Okay, thank you.
Sure. Okay. So yeah, so everyone, when you create a queue, always make sure to double click on the queue and just change it to queue as opposed to conveyor. Otherwise, your results will be different. It's a queue, so you have to check the queue. One other thing that I want to also mention here is that when we had the these other icons, maybe you guys didn't pay attention to, but we can always open the previous version and check. Here on the rules, everything was oldest. But here, when you create a queue, by default, the rule is FIFO. Can you tell me what is this? What does this mean?
First in, first out.
First in, first out. That means when people are waiting in the queue, always the first person in the queue is the first person that's going out to go to the barber. Okay, so there is, by default, the queues have this rule in terms of how people wait and how people go from the queue to the next operation. So if you want to change that, all we have to do is double click, pick this row first, and then double click on the rule, or just click on the rule. And then this window opens. So check, select the row, this row waiting area, and then click on the rule. Okay. So as you can see here, the one that has been selected is first in, first out. You see? We can change it to last in, first out. The last person that has come in is the first person that is going to go out. This may work for scenarios like an elevator. In the elevator, always the last person that comes in is the first person that goes out. And a couple of other options for making for type, looking at their type and things to find out who is the entity that is going to go to the barber first. However, there is also another option which is called no queuing. What does no queuing mean? No queuing means there is no rule here in the waiting area. All of the customers that come, no matter when they arrive, can be chosen to go to the barber next. There is no rule. As if every customer that is waiting here is always the first person that can go to the barber, is always the first person in the line that can go to the barber. No matter what time they arrive, anyone has the same chance of being the next customer that goes to the barber, as if every customer is always the first person in the line. If I pick a location for the area and I choose no queuing as the rule, then the simulation treats everyone as if they are always the first person in the line and they can always be the next person that goes to the barber. That is why in these scenarios, when simulation calculates the waiting time, everything is reported as a block time, because as if every customer is always the first person in the line and every customer is blocked obviously by the one that is already here. However, this is not the case. This will not be the case if I check first in, first out, because in that scenario, the customers wait in the line and there is only one customer as the first customer that can go to the barber next. So all of them wait in the line. The rest have waiting time, and only the first customer in the line, when that person becomes the first customer, will collect block time. Okay, so for now, just to see it, check no queuing, press OK. You see here, you don't see anything, any first in, first out. That's what happened in previously when we use other icon. The default rule was no queuing. But if I click first in, first out, and then press OK, you see first in, first out. So let's keep it as first in, first out and run the simulation one more time, but save it before we do. Run the simulation.
What does the oldest by priority mean then?
We'll get to where's All
For
the
selecting incoming entities.
no. We will get to those. Those are for, so there is a bunch of rule here. Selecting a unit, incoming entities. The ones that you have to pay attention to here is the rule in the queue, queuing for output. Okay, so this part is the only part that I want you guys to pay attention to. We will get to all of these parts throughout this class, explain all of them, use all of them. But let me explain it when we get to them so that you guys better understand what do they mean. For now, all I want you to pay attention to is the queuing rule here.
Okay, thank you.
Okay, person. Okay, before we run, guys, let's go back. Remember, we deleted the waiting area and we added a new one. Let's go to the arrival. Since we deleted the previous one, this one also is deleted. So let's go to click on the location and just define the waiting area again. Obviously, everywhere we used waiting area previously, since we deleted it and added a queue, that previous one is deleted. Also, let's go to the processes. Also here in the first line where we had the waiting area, that one is deleted as well. So let's pick the waiting area for that again as well. So everywhere we had used the waiting area is deleted because we deleted the previous location and added a queue. So let's just go back to the processes and to the arrival and put the waiting area back again. Make sure to save and then run. Okay, so still 47 customers and there were 32 minutes time they have spent in the system from the moment they came to the moment that they left. I want to check how much of this time is the operation time, how much of it is the waiting time, and how much of it is the block time. Where should I go to see that?
Entity summary.
Tables, entity summary. Okay, so out of these 32 minutes, you see here, now I have value for waiting time. Previously, waiting time was 0. Now I have value for waiting time. About 17 minutes, they are in the queue, but the second person or third person or whatever. And then about 6 minutes, they are the first person in the queue. They are still in the queue, but they become the first person. And then they go to the barber and they spend about 9 minutes with the barber. Okay, so basically all this waiting time and all this block time together, they are still waiting time. I mean, I personally don't care much if you are the 10th person in the queue or you're the first person in the queue, you are still waiting. So all the time of waiting and the block time are part of the waiting time. I think I got, okay. Okay, I'm going to explain this one more time if my voice got off. So here we see the time waiting in the queue. That's the time that the customers have been waiting in the queue. But the second person or the third person in the line or the 10th person in the line, as soon as they become the first person in the line, the simulation records that time as part of the block time. And then they are ready to go to the barber. And that's when they spend about 9 minutes with the barber. But all this time, waiting time and block time, they are all waiting time in the queue. No matter if you are the first person in the queue or you are, I don't know, the second, third, 10th, 20th person in the queue. All of them are part of the waiting time. So you just be mindful about what these numbers mean. So when you want to report this to your boss, to your customers, if you're a consultant, you report both of them as waiting time. But mention that, okay, this is the time when you are the first person in the queue, but it still is part of your waiting time. And
If we're asked like for a total waiting time, could we just say like around 22 minutes?
yeah, definitely. You can do that. Just add the waiting time and the block time and report all of that as the total waiting time. But, and that's when we teach operations research 2, 417, 4170, all of them are the calculations that we do, consider all of them as waiting time. But in ProModel, they have divided this into block time and waiting time. But you know that both of these together are basically the waiting time of the customer. That's how you see how this 32 minutes is divided into a waiting time, a block time, and some operation.
Professor, I
Go ahead.
didn't get the same numbers as you.
You did not?
No.
That's fine because we are using different computers and different random numbers, but also are your numbers very different or
Very different.
okay, I'll
Yeah.
check your model. Let me check your model then.
Okay.
I'll check your model in a second, but let me make sure I finish everything I wanted to talk about. Okay, and we saw the waiting time was calculated only because I picked the queue as a queue with the first in, first out rule. If I go here and I change the first in, first out rule as to no queuing, let's see what happens. Change the rule to no queuing. You still it's a queue, but change the rule as opposed to first in, first out, change it to no queuing and run it again. I want to again see this time, so I go to entity summary. You see what happens? They have spent about 32 minutes in the system, but I don't see any waiting time. Everything I see is block time. All that 23 minutes is recorded as block time here in the simulation. And obviously I see about 9 minutes operation time, but that time, which was part of it waiting and part of it the block, now is all block time. Why? Because when I do not define the first in, first out, when I pick no queuing, that's as if this location is just a placeholder. It's just where it holds the customers. There is no line, there is no rule. Every one of them can be chosen randomly to be the next one that goes to the barber, no matter if you arrived just now or if you have been waiting here for 10 hours. It doesn't matter. As if every one of them is the next person that can go to the barber. As if all that waiting time is considered as block time because you are looked as the next person in the line that can potentially go to the barber for all the customers. So all the time you are waiting here, it's recorded as your block time, not as your waiting time and then block time. So that's why we see the results that we see in this scenario, and that's perfectly fine. But all I want you guys to be able to do is to be able to recognize this. If you do not see any waiting time, don't say that, oh, they don't wait at all. Is make sure to go and check what is the rule here. If the rule is no queuing, yes, that makes sense. Everything was calculated as block time. This is the whole waiting time. That's the whole 23 minutes that previously was divided between waiting time and block time. So make sure you guys know the differences between these two scenarios. Make sure you guys can make sense of the numbers. So if I see something like this, I wouldn't conclude, oh, there's no waiting time. I would definitely come back and check the structure of the model to see why those numbers can calculated the way that they were shown. And then I will check again. Does it make sense for a barbershop to say no queuing? No, it doesn't make sense actually. I think in a barbershop, first in, first out rule makes sense for the waiting area. So put the rules that do not make sense. If you're modeling a manufacturing process where the first operation they just done with the part and they just put it in a pallet and then the next operator just picks any part from the pallet, no matter if this part was done with the first operator 20 minutes ago or it was done just right now, yeah, for those I will put no queuing because that pallet is just a placeholder. I finish, I put it in the pallet, the next guy can pick any one of the parts from the pallet and process. Yeah, for that one, it makes sense. No queuing makes sense. But for a queue, when people really stay in a queue, in a restaurant, in a call center, in a supermarket, then first in, first out rule would make sense. Okay? So make sure you guys are mindful about the importance of the rules that are defined here and how they affect your numbers. And if you will see that sometimes we develop a model you guys may pick a queue, I may pick a location, and then we see some differences in our numbers, and then we're like, why did it happen? And that's because some of these locations have some default rules, and we have to be mindful about those. Otherwise, just be mindful. It's fine. As long if that's what makes sense, more sense for your system, that's fine. But know that if you pick this is how the results are reported, and vice versa. Is there any question?
I have a question, Professor.
Go ahead.
So when we did first in, first out,
Mhm.
you're saying that the block time is for the first person in line, but shouldn't block time then be this similar to time in operation?
No. Block time. Okay, let's run it again and see what it means.
Mhm.
Okay. So block time is this. So let's assume you and I and Will and someone else are in the line to get to the barber. You are the first person, I'm the second person, and let's assume someone else is behind me. So this time is considered, at this time that I'm waiting in the line is counted in the simulation as my waiting time, okay? So that time, let's say, assume I'm in the line 2 minutes, 3 minutes, 5 minutes, whatever minutes, 10 minutes, all of that is my waiting time. And let's assume the barber is done, then you are...
You're cutting out, Professor.
Do you hear me now? Do you hear me now?
Yeah, I can hear you now.
Okay, so I think it's going to get disconnected again. Do you hear me now?
I can still hear you.
Okay, if I get disconnected again, let me know.
Okay.
So I'm in the line. I'm the second person in the line. You are ahead of me. And I wait 10 minutes. All of that is considered as my waiting time. Then it's your turn to go to the barber. Now I'm still in the line, but I become the first person in the line right now. Then simulation automatically starts to start counting that as my block time. So let's assume when I become the first person in the line, for 5 minutes, I stay the first person in the line. That 5 minutes is my block time. That 10 minutes when I'm in the line, not the first person, but somewhere in the line, is my waiting time. Does that make sense? Could you hear me? Or
Yeah, that makes sense. It's just if there's only one ATM and the person at the ATM takes 5 minutes, then wouldn't the first person in line have to wait for that person to be finished, which is 5 minutes?
But then we have other values as well. For the first person that came to the line, okay, that's not always the case. Let me give you an example.
Okay.
Okay, let's assume the first person comes to the system. Obviously, for this first person, the waiting time, W, is 0. The block time is 0, right? Because the person comes, no one is in the line, no one is in the ATM, the person goes directly to the line.
Mm-hmm.
The second person comes. This person comes, there's no one in the line. So what is the waiting time with that person? So there's no one in the line. There's someone in the ATM. So this person immediately, the second person that comes immediately is the first person in the line, right?
Mm-hmm.
So there's no waiting time, but then there is some block time. Let's assume the previous one is already at the ATM for 5 minutes and the second person has just arrived. Let's assume this person needs to wait as the first person in the line for 2 more minutes.
Okay.
Till the first person is done. And the operation time of the first person, let's assume is 7 minutes. So at minute 5, the second person comes, stays as the first person in the line, but already 5 minutes has passed, the person has to wait 2 more minutes. Till the guy in the ATM is done, the person goes to the ATM. So this is just one example when the operation time is 7 minutes, but the block time is just 2 minutes.
Oh, that makes a lot more sense. I was just assuming that the people were coming like one after another.
You are right. At some point in the system, we will get to that point, but that's not always the case. Simulation, there are times when the line will be empty, and then again a bunch of people comes and it's full, and then it becomes empty, and so forth. So all these scenarios happen in that 10 hours of simulation.
Okay, that makes a lot more sense. Thank you.
Sure. And guys, what we see in the simulation when it's reported, so these all the first line, all the first numbers of waiting time or block time or operation time are for the first customer. All the second ones, 0, 2, and let's say the second customer has an operation time of 9. All the second numbers are for the second customers. And we get waiting time, block time, operation time for the third customers, for the fourth, fifth, seventh, all the way. The numbers that you see reported here, the average time in the system, the time waiting, the time in operation, the time block, these are for all the customers that have come to the system that in that 10 hours. So those numbers that we see are average of all these numbers. So a bunch of other numbers, let's say the other customer comes out and has to wait in the line for 3 minutes before it goes to before the person becomes the first person and has to wait in the line for, I don't know, when the person is the first person has to wait for 5 hours, and then finally goes to the operation, and then it takes him 3 minutes, for example. So the numbers that we see as the waiting time in the line is average of all these numbers for all the customers. The number that you see reported as the block time is average of the block time for all the customers in the system. The number that you see as operation time is the average of operation time for all the customers that have come to the system in that 10 hours. So the numbers that we see here, that's how they have been calculated and they have been reported. Your average of all the waiting times for each one of the customers. All these 47, there are 47 waiting times, one for each customer. Average of them is this. There are 47, because our total exit is 47, right? 47 customers have come, have gotten the service and have left. There are 47 operation time, average is this. There are 47 block times, average is this. There are 47 total time in the system, average is this. So I want you guys to know how these numbers have been calculated. And they are reported in this ProModel. Okay.
So if we wanted to find out how long people are waiting, including the block time, can we just add those averages up, or is that not how that works?
Yeah, so that's exactly what we have here. Average time in the system.
Okay.
The average time in the system from the point that they enter till the point that they leave. From the point that they enter, first they have waiting time, then they have block time, then they have operation time. Add them all, that's the total time in the system.
Okay, thank you.
Sure. Any other question, guys?
Professor, I got 2 questions not related to this specifically.
Okay. Go ahead.
Number 1, looking at the barber problem, it says simulate the system for 8 hours. I can't remember where do you put that 8 hours at?
Here, do you have simulation options?
Let me see. Oh, okay, I see it. Yeah.
That
oh, okay, okay, cool. And I have one more question. Looking at my, sorry. Okay.
Go ahead.
Okay, looking at my model, under entities, under speed, I have FPM and I have 150. I can't remember what that means.
This is the speed frame per minute. That's basically the speed that we see during the animation.
Okay.
Yeah. So don't change it. We are not going to play with it. We are not going to change it.
Oh, okay. Okay, sounds good.
Change that number.
Okay, thank you.
Sure. Any other question, guys? Stop. Okay. What time is it? Okay, guys. Let's take. It's 2:33 right now. Please be back in 10 minutes by 43, and then we'll go through a different model and learn some new techniques in doing that model. So if there's any question right now, let me know. If not, please make sure to save your models. All of the models we did so far, save all of them in folder for week 2. Take 10 minutes break and then come back for the continuation of the class.
Professor, I have a question.
Go ahead.
Can I share my screen with you?
Sure, go ahead.
So when I run the simulation, Professor, it doesn't match up the numbers
Okay,
with yours.
yeah. You are the one who said your numbers are different, right?
Yeah.
Okay, let me check. Okay, I know exactly why. You see here in your first line, Barber, why go to the first line, click on the first line in the processes.
Processes. Oh, sorry. Here.
Yeah, click on the first line. You see your barber. First of all, when the customer comes, the customer is not at the barber. The customer is at waiting area right away, right? So in your waiting, yeah. So change that. Click, yeah, waiting area. And where does the customer go from the waiting area?
Waiting area to the barber.
To the barber. Click on the destination.
Destination.
The first line. No. The first line. The first line. Go.
Oh, I'm sorry.
So the customer is already at waiting area. Then in the right side, you put the destination. Where does the customer go from there?
Slow.
Do you hear me? Do you hear me?
Professor?
Do you hear me? Do you hear me now? Hello.
Professor?
Do you hear me?
Yeah, I can hear you now.
Okay. So now in the destination, we need to pick the barber here. Okay. Mm-hmm. So basically we say customers go from the waiting area to the barber. Okay. And then next line, click on the same. And then the customer goes from the barber to exit.
Barber to exit?
Okay.
Yeah.
However, that processing time that you have is not the processing time at the waiting area. It's the processing time at the barber.
So this is gonna here.
Yeah. Exactly.
Okay.
Do you understand now what's happening?
Yeah, I understand. So the customer goes from customer goes to the waiting area, and from waiting area it goes to the barber, and barber to exit.
So click on the first line. The destination on the right side changes when you click on the which line. If customer goes from waiting area to the barber first.
Okay.
Which is the one you had, and then in the second line, the barber goes to exit.
Okay.
Does that make sense?
Yeah.
Okay.
Now let's run the simulation. Let's see.
You see your results?
Yeah. How do you get the other table, Professor? The entity something table?
Table. And then entity summary.
Entity summary.
I don't see your results, so I can't tell you that. Do you want to share your results?
Here. Is that what it is?
I don't see it. I think your screen is just showing the model.
Okay, let me stop sharing and share it back again.
Okay.
Can you see it now, Professor?
Yeah. So yeah, entity summary, that's where you can see the time in the system, the waiting time, the block time.
Yeah, that makes more sense. So the customer, the total time is this, and they wait about time in operation, block time, and you said the block time is the waiting time?
No, block time is the time that they are the first person in the line.
Oh, I see. Thank you.
So what we want to do next is to build another model. And this is the structure of the model that we want to work on. So in this model, we want to learn how to put multiple locations and multiple entities into the model. So the first thing I want you guys to do is that in the folder for week 2, create a new model and name your model as week 2 dash furniture factory dash multiple locations and entities. So please create a new model in the folder for week 2, file, new model, and then save your model in the folder for week 2 and name your model as week 2 dash furniture factory dash multiple locations and entities. I want you guys to for sure use this naming structure that I'm giving you, because I try to put something that shows what we are learning in that model at the end of the name. That way, for the exam or for practice or for project later on, if you want to learn, if you want to just see, oh, which one was the one in which we, for example, learned to do this, you can just look at the name of the model and just see those keywords at the end of the name of the model, and you can say, oh, that's the model in which we learn how to put multiple locations, for example. So please follow this naming convention, because that helps you a lot later when you want to come back and retrieve some of these models for taking a look at them for the exam or for the homework or for the project or anything. Okay, so once you do that, so stop, don't do anything else. If you're done, then this is the structure of the model that we want to develop. We have a receiving dock. Our entities, which are logs, come to the receiving dock. A receiving dock has capacity of infinity, meaning that it can hold as many logs as it comes to it. The logs then go to the splitter saw, and each log is being split into 2 pieces. I forgot to put the number 2 here, but 1 log comes in and 2 pieces come out. So in the splitter saw, the splitting operation has normal distribution with average tree and standard deviation of 1. Then these pieces go to the lathe machine. And in the lathe machine, the processing time has this distribution. Can someone tell me what is this notation? What does that mean? The distribution of the time at the lathe machine?
Triangular.
Well, okay, and what are these parameters?
The min, mode, and max.
Is there the minimum, mode, and the maximum triangular distribution? So this is a distribution of the processing time on the lathe machine. And then also pay attention that both the splitter saw and the lathe machine have capacity of 1, meaning that they can process 1 part at a time. Then the parts that come out of the lathe machine go to the paint booth. The processing time at the lathe paint booth has 5 minutes exponential distribution, and the also capacity of paint booth is 1 part is being processed at a time. And then the paint, so the parts that comes out of the lathe machine is round leg. Round legs are the ones that go to the paint booth. They are painted, and then the painted leg is the entity that is coming out. Then painted leg go to the painted leg store, and from there they exit the system. Okay, so the logs come in and they go to the splitter saw. They come out as pieces. Pieces go to the lathe machine. They come out as round leg. then they go to the paint booth, and then they come out as painted leg, and then they are done. One other piece of information that we have is that the logs or legs come to the system 1 every 17 minutes. Okay, we have that as we come to the system 1 every 17 minutes. So we want to be able to model this. Now, the question that I have for you is that how many locations there are in this model?
Is it 5?
5 locations: receiving dock, splitter saw, lathe machines, paint booth, and painted leg store. Someone in the class on Wednesday asked, what if we put 9? Also, some waiting area for logs, some waiting areas for pieces, some waiting areas for round leg, and some waiting areas for the painted leg. And that's fine, but you can do that. But here, I haven't asked for that. These arrows just show the direction of the entities. Where do they come and where do they go? These arrows here do not represent a queue or a waiting area. You can definitely put queue or waiting area if the problem says they exist, but here they don't. So when a part is done on the splitter saw, it goes to the lathe machine. It doesn't go to the waiting area first, and then to the lathe machine. And if the lathe machine is busy, what happens to the part? Let's assume the part is done on the splitter saw, but the lathe machine is busy. What happens to the part?
Does it just stay in the splitter saw?
Yeah, it just stays on the splitter saw till finally the lathe machine is done, and then the part goes to the lathe machine, which is obviously not an ideal scenario because we don't want to keep the splitter saw busy, because then when the part is waiting, it's done, but it's waiting here because the lathe machine is full. Still, the splitter saw is considered as full. It's not going to process another part. So we don't want situations like this. That's why we put intermediate queues so that when the splitter saw is done, they can put the part in the queue and start processing another part, and the lathe machine can pick up and process this part whenever the lathe machine is done and is ready for another part. That would be the ideal scenario. However, in this problem, just for the simplicity, we do not have those intermediate queues or in intermediate locations. We just have 5. And when a part is done on the lathe, goes to the paint booth right away. And when a part is done on the paint booth, goes to the painted leg store right away. And then from there, they exit the system. Okay, so 5 locations. How many entities there are in this model?
4.
What are those?
The log, the pieces, the round leg, and then the painted leg.
The logs and the pieces and round leg and the painted leg. These are 4 entities. Obviously, they come to the system as logs, but then they are transformed to other entities in the system. Okay, we want to have that as well. And then how many arrivals do we have? Remember, we defined the arrival for the entities.
Is it just 1?
Why do we have only 1 arrival? We have 4 entities. Why do we have 1 arrival?
Four arrivals?
No.
Because everything starts from the logs.
Because everything starts from the logs. Because we define the arrivals for entities that are coming from outside to the system. Here we have 4 entities, but only one of them is coming from outside. Logs are the ones that are coming from outside. The rest are created inside the model. Pieces and round legs and painted legs, they are created inside the model. So we just define them in the processes. But the only entity that is coming from outside is the logs. So we have only 1 arrival for the logs. So arrivals are always for the entities that are coming from outside. If you have 3 entities that are coming from outside, perfectly fine. Define 3 arrivals. But arrivals are always for entities that are coming from outside to your system. And here logs are the only entities that have that condition. Okay, so And this is all I have about the arrival. Logs come to the system 1 every 17 minutes. So with that in mind, when the logs come to the system, where is the first location they go to?
The receiving dock.
They go to the receiving dock, as you can see here. What is quantity each? Let's assume we are defining everything in the arrival. We are on the arrival part of the Pro model. The logs come in, they go to the receiving dock. What is quantity each?
Is it one at a time? Yeah.
One.
One.
Because
we're looking
at the system one at a time.
Because it says in the problem, logs come to the system 1 every 17 minutes. It doesn't say the logs come in batches of 5 or the 2 logs come every 17 minutes or so. It just says logs come 1 every 17 minutes. So they come 1 at a time. So quantity each is 1. And then what is first time? In the first time column?
0.
0, because they can come to the system from the start of the simulation at time 0. What is occurrence?
What?
No, it's infinity.
Okay. For the person that answered 1, what is the meaning of 1 for the occurrence? So can someone tell me what does it mean if I put 1 for the occurrence?
It will only happen one time.
It only happens one time. You only get one entity and we are good. And we are done. When we put infinity, that means entities will come to the system for as long as we run the simulation. And here I haven't mentioned anything about a limit on number of logs that would come to the system. So you just put infinity because there is no limit on how many logs would come to the system or can come to the system. And then, okay, and then that's occurrence is infinity. And then how about frequency?
It's going to be 17.
Can you tell me why?
Because it says it comes once every 17 minutes.
So what is this number? Is it arrival rate or inter-arrival time?
Inter-arrival time.
It's inter-arrival time because logs come every 17 minutes. So the time between arrival of 2 consecutive log is 17 minutes. And so that's 17. Is this fixed or random?
Fixed.
Because
no average.
I think it's average.
Okay, you do not see the word average first. And then if you see the word average, then you also have to look for something else here that tells you what is the distribution of this random variable that represents inter-arrival time. Okay, so here the inter-arrival time is fixed, 17 minutes, and that's all we need. So what I want you guys to do is to, in the model that you created, in the new model that you created and saved, I want you guys to create the locations. Make sure to put the label of all the locations in your model. I'll check your model, guys. Create the locations, create the entities, create the arrival. We do the processes together because you still don't know how to create different entities and so forth. So in the process. So just do the first 3 steps. Do the locations, do the entities, do the arrivals, and then we do the processes together. Guys, for the location, when you put the locations, make sure that the receiving dock has capacity of infinity. The rest have capacity of 1. Okay. So I assume everyone is done. Are you guys done with the locations, entities, and arrivals? Everyone is good?
Yeah.
Okay, perfect.
For the rifle, Professor?
Go ahead.
It's just the locks, right? Because that's it, right?
For which part? For the entities or arrival?
For the arrivals.
Yeah, arrival, we have only one for logs because logs are the only entities that are coming from outside.
And for the frequency, it's 17 minutes and it's fixed, right?
Exactly, 17 minutes, because here it tells you they arrive one every 17 minutes. It gives you the inter-arrival times directly, so you don't need to transform it into anything. And then you don't see the word average. It doesn't say inter-arrival. They come to the system one every 17 minutes on average. Since you don't see the keyword average, that means this 17 minutes is fixed. So you don't need to worry about any distribution or anything like that.
Right. Thank
Okay.
you.
Sure. So just to make sure, can one of you share your screen, just volunteer to just go over it and make sure everyone is on the same page. Thank you. Can you go to your locations? Okay. We have the receiving dock, splitter saw, lathe machine, paint booth, and painted leg store. Everything has capacity of 1 except the receiving dock, which has capacity of infinity. And all the units is 1. There's just one location of everyone. Just note that here the receiving dock has no queuing rule in it. Let's assume if we want. So can you double click here on the rule? Yeah, here you see receiving dock has no queuing rule. Just keep that in mind. If that's really something that you want to consider and that works for your system or not. You can leave it as it, or you can keep it as first in, first out. Just make sure that whatever you do, you are aware that how it can affect your results, but pay attention to these setups of your model. Okay, can you go to the entities, please? And he has also put the label of the location, so that's great. Can you go to the entities, please?
It's not letting me click out.
Put escape.
Yeah, it's still not letting me do anything.
Escape or OK, none of them. Even if you press the keyboard, none of them work.
It's pretty buggy. You gotta just keep trying.
Yeah, nothing is
Seriously,
working.
I had never experienced anything like that. That's okay. Can you go to? No, that's fine. Damir, I appreciate it. Did it work? Oh no, oh, it's somewhere else. Can someone else?
I just moved it somewhere else.
Okay. Can you go to the entities? Okay. We have logs, pieces, round legs, and painted legs. Can you go to your arrival? Logs come to receiving dock one at a time, infinities, 17 minutes, and so forth. Perfect. So, guys, I'm going to end the session today just to stay on the same time frame with the previous one. In the previous class, I think it just took longer. We couldn't proceed with the processes. So keep the model as is. But when we come back next session on Monday, we go through the processes all together. Okay, just to be on the same time frame with the previous session, I will stop the class now.